Bob Wormsley here from INSYDIUM, and in today's video tutorial we're going to go back and revisit an older scene. This is by our head of design Mario, and it's a good one. This is our dynamic spider's web. So this is what we're going to recreate, these fantastic, stretchy, snappy, sticky webs. These are dynamic and we're going to use X-Particles constraints to make them. The advantages with this is that they're really quick to set up and they're fast to simulate. The disadvantage with this method is that the actual trails themselves aren't dynamic. It's the particles that drive them, and therefore there is some trail geometry intersection. But depending on your scene and your camera position and angle, you may get away with it. So if you can, this is a fantastic method to use. So let's jump into Cinema 4D and get started. Right, so first of all, we're going to build our kind of barrier which our spider webs are going to stick to. So let's bring in a cube. And this cube, the default is 200 by 200. Let's put that down to say 40 by 40 by 40. And then what we want is a load of copies of these. So we'll use the Mograph cloner for that. So with the cube selected, I'll hold Alt, and then we'll go to Mograph cloner, and that automatically makes the cube a child of the cloner. And by default, the cloner is cloning these in a linear way on the y-axis, and it's making 3 copies. So we want a big kind of 2-dimensional grid. So let's change the mode from linear to grid array. And the count on the x-axis, we want, I don't know, say 8. On the y, we want 8. And on the z-axis, we just want 1, because we don't want any depth to it. So now we've got all of these clones, but they're so close together we haven't got any gaps in between. So let's just increase this size until we get something. We want some gaps, but we don't want the gaps too big, because we want enough for the web to kind of bridge across. So 587 looks good. Let's change the Y to 5872. And now we've got this big grid of squares. So that looks like it's going to be a good wall for us to be firing our spider's webs at. Excellent. Let's go. This grid is putting me off. Let's go to filter, and we'll just deselect the grid. All right, that's better. Right, so let's sort out our particles. Actually, before we do, let's just tidy up this scene. So I want all of these clones to be a collider object, so particles can collide with it and interact with it. So what I'm going to do, I'm going to put this cloner as a child of a connect object. So let's hold Alt with the cloner selected, and we'll go to the menu where we've got the connect and select that. And the connect, we don't need to weld the points together, but we don't want it to be connected. And I'm going to just change the name from connect to, let's just call it wall, so we know what we're doing. Excellent. And then on the wall, on the connect object, this is where we're going to put our X-Particles collider tag. So let's go to tags, X-Particles tags, collider. And we can mess around with these settings once we've got our particle system set up. But I know that I'm not going to want bounce, and I'm going to want 100% friction, because I want the particles to stick to these this grid. Excellent. Right, so that's that sorted. Let's bring in our particles now then. So we'll go to the X-Particles menu, and we'll bring in an XP system, which is a really good way of staying organized in your scene. So by default, our system brings in, I'll just move it back. I don't want to move the system. The emitter, it brings in a default emitter, which is set to rectangular emission, and it's spitting out particles on the Z-axis. That's not what we want. What we want to do is create a kind of a firer to create this web. So we want it to be circular, and we want the particles to be emitted in kind of a regular pattern. So what's the best way of doing that? Well, what we could do is use a disk object. So let's bring in, this is just a parametric disk. I'm just going to move it back a little bit. And if I hit, we can't see the lines and the segments here. So let's hit ND, which reveals the lines. There they are. This is how the disk is made up. So let's go into our disk settings, and let's just actually rename this straight away. Let's call this Web Shooter. Right, so the disc has 4 segments, 1, 2, 3, 4, and it has 36 rotational segments, which are these ones, 1, 2, 3, 4, 5, all the way to 36. So we want this to be emitting particles from either these points, or we could probably do it from the polygon center. Let's just get that set up first, and then we can make tweaks. So in the emitter, we'll go to the Object tab, and instead of the emitter shape being the default rectangle, let's change it to Object. We'll drag in our web shooter, and we'll just keep it at polygon center for now. And I'm going to do 1 particle per source element, which means we're not going to get any kind of particles on top of particles. We'll just have 1 per polygon center. And then in the emission, I'm going to change the emission mode from rate to shot. And let's just leave it at that for now. So at the moment, the disk is facing in the wrong direction. These are just going to fly upwards, these particles, and that's not what we want. So let's reorient it in the web shooter. If the orientation of this parametric disk is on the plus Y axis, we want the plus Z, this blue direction. So let's change that to plus Z. So now they're being fired at our wall, and the particles are kind of interacting with this when they hit. Let's put some more frames on our timeline. Put that up to 500. So these particles have stuck to it. All right, not looking very dynamic, not looking much like a spider's web yet. So let's reduce the size of this disk because it's way too big, down to, I don't know, maybe like 30-ish. 29 is a good number. And I think what I want is more disk segments. Let's put that up to say, I don't know, something like 15, and let's put the rotational segments down a little bit. I don't think I need that many. So you can see the idea here. We're starting to get something that once we join up these particle lines, they will start looking a little bit like a spider's web. Now, can you see one thing, one quirk? A lot of people get confused by this. If I go to a kind of a side view, or even if I hit F5 to bring up all of the orthographic views, and if I go to this right view here, you can see that even though all these particles have emitted on the same frame, they're all at kind of different positions, even though in the emitter, they've got the same speed, and they're shooting out on the first frame. And that's because we've got Subframe Emit selected, which is on by default. So if I just uncheck Subframe Emit and hit play, you'll see that they're all absolutely perfectly lined up because they've all been emitted at exactly the same time. So that's why that happens. And it's Subframe Emit's really useful because it means if you're emitting per frame, you don't get that very steppy emission. It blends from frame to frame much more nicely. But good to know. Right, so at the moment, these particles are all going out and they're being shot out in the Z direction of our disk. But we want them to be kind of firing outwards. So the way we're going to get that look is we're going to use a Cinema 4D deformer on this web shooter disk. So with the web shooter selected, I'm going to hit Alt, go to my deformers menu, and we're going to use this one called Spherify. So let's stick that in. And oh, actually, I've done that the wrong way around, haven't I? I've made the disk a child of the Spherify, and I actually wanted to do it the other way around. And to do it the other way around, you would hold Shift and click it, and it would make the Spherify a child of the object. That's what we want. In the Spherify, let's hit Fit Parent, and then I'm just going to move the Spherify backwards, and there, can you see it's kind of bulging our disk? You don't want a bulged disk, but we do in this instance. Right, so there we go. So now if I hit play, they're firing outwards, which is much more the kind of movement that we want. So that's looking good. Okay, so we're getting there. So our web shooter's looking good, and our particles are shooting outwards. Now, they're not shooting out quickly enough yet. If you think about them, we want them to like and firing out. Plus, we want a gravity in the scene. And if they're going this slowly, the gravity is going to take them to the floor before they've even interacted with our wall. So let's just bring that gravity in. Go to modifiers, motion modifiers, and let's bring in a gravity. So if we hit play now, they just all drop to the floor. And that's because they haven't got enough speed. Also, the gravity is pretty strong. For now, let's just reduce that strength of the gravity, but they're still falling to the ground. So in the emitter, we're going to do a couple of things. In the emission, let's put the speed way up to like 1,000. That's really splashing them out, isn't it? That may be too much, but we'll leave it at that for now. And what I'm going to do, I'm going to put some variation in as well of 200. So now we've got variation in those, which will make sense. That variation will make sense once we have got our webbing, our dynamic webbing sorted. So there we go. We've got these particles firing out and interacting with our wall. Let's just, before we start doing the dynamic stuff and kind of linking these particles together, let's just, with our web shooter, I'm just going to orient it upwards. Let's just, there we go. Right. So that's looking good. So what are we going to do? How are we going to connect these particles so they form this web? Well, we're going to use something called constraints, which are a dynamic object. So if I go to my dynamics menu in Xparticles and bring in a XP constraints. Now, XP constraints have all of these different options. We've got connections, collisions, forces, viscosity for fluids, friction, surface tension for fluids as well. Massively powerful and hugely feature-rich object, the XP constraints, but we just want to connect particles together. And we want to connect them when the particles are born. So we'll stay in this birth tab. We'll click connect at birth, and what's going to happen is the connect object is going to connect particles together with a spring, and we can set how bendy or how rigid that spring is, and we can also set how many particles are linked together. So I'm just going to leave in its default settings. If I hit play now, the particles are going to be behaving a little bit differently, but it's hard to see what's happening. You can see that some of them are clumped together. So that's because we're not actually viewing the springs that we've created. So let's go to the emitter. We want to look at these springs. So we'll go to the display tab, and let's change it from dots to squares so we can see the particles a bit better. And we will also check this one, display constraints. Click that on. Now hit play. Now, if I just dolly in, you can see that some of these particles are connected by these constraints. This is it. But not many of them are connected, and they kind of lose that connection. Let's go back to the constraints to find out why. Well, first of all, we've got a breaking mode on, which means the constraint can connect the particles, but then it can be broken if the particles move away from each other too much. So let's just switch that off for now. So we've got no breaking. Okay. So there, that looks more interesting, doesn't it? So now if I dolly in, these particles are connected in this really interesting way. So what's happened? Well, let's have a look. The connection limit is 8. And we have this radius of 40 centimeters. So what that's saying is, let's just look at this particle here. This particle is going to look within a radius of 40 centimeters of itself, and it's going to connect to up to 8 particles within that radius. And then this one will, and then this particle will, and it'll keep connecting all the way around until we get this really interesting pattern. So what I want to do, I don't want the radius to be too much, so let's just reduce that radius down, but up this limit to say 15, and let's see what we get. Okay, so that's interesting. You see, it's so tight, these springs. As soon as it's emitted, it's kind of like pulling in on itself, and then it's pushing out and it's bouncing, and it's not kind of what we want. We've got a stiffness of 80%. So I'm going to reduce this way down to say, let's just try 8% stiffness and see what happens. Ah, so you see, it's not as strong now. And you can see the effect already, can't you? I mean, it's kind of looking a bit web-like. So very quickly, we've kind of got the look we want. So a couple of changes. The particles are, see the green particles, they're interacting with these cubes, but then see these three here, but then because they're being pulled around by these springs, they're kind of slipping and sliding over the surface of the cube. I want them to be a bit more sticky. So let's just go back to our collider tag. We've got friction set to 100%, but always remember that we have per particle friction amounts as well. So we need to go to the emitter, extended data, physical data, and we have these are the per particle amounts. Now at the moment, friction in the emitter is only set to 20%. So what it's saying is all of the particles have 20% of this friction amount when they collide with the object. We wanted to put it up to 100%. So they're completely sticky. Let's have a look. That's sticking much better, isn't it? And that's kind of the basic look. I mean, it's very simple. So what else do we need to do to make this look interesting? Well, we want to bring a little bit of breaking. I think we want some of these spiders' webs to actually break once they experience sufficient force. So let's break. Let's put it back on. We'll go break as, and I'm going to put relative connected. So what this means is we get this percentage. And what it is saying is the distance between the particles, let's just bring some up. I'll put that up to 500 for now. I'm just going to dolly in. So relative connected means this. When the particles are born, it judges the distance between them. So let's just take this particle. I'm just going to change the colour of my particles so we can see this a little bit better. I'm going to change the squares to circles filled, and I'm going to make them bright pink. Okay, go back to the beginning. Right. Ha! Too big. Let's put that down to 1 centimetre. And I'll put my ambient occlusion on in the viewport and go again. Right, here we go. So what relative connected does in our constraints is this. It looks at how far apart the particles were when they were born. So let's just say this particle and this particle. And it makes the connection. But then it says, depending on how far they're away, if they move away from each other, I've got it set to 500%. So 500% of this original distance, then the spring will break. If they stay within that distance, within 500% of this original distance, the spring will never break and they will remain connected. But if they stretch so much that they go beyond this 500%, then that will break. So let's leave it at 500 and see if it is enough to get a little bit of breakage once the particles hit our wall and once the gravity starts taking effect. So it's too much. The force of the particle's speed and this very low stiffness means that those springs are stretching and then they're getting beyond this break limit and they're snapping. So let's put that up to 1,000, see what we get. So that's holding a little bit, but they're still breaking too much on impact. Let's put it up to 2,000%. Starting to get interesting. We're getting some bits hanging on and some falling off. Let's put it up for more. Let's say 4,000%. So there's no breakage at all. And I do want some breakage. Let's put it down to 3,000. All right, that's looking not bad. Let's put that stiffness down to 7, see if we can just encourage a little bit more. And the gravity, why don't we put the gravity back to near default and see if that'll encourage a bit more braking. I want to see some braking. Let's try 2,700. Okay, well that'll probably do for now. So this is our first spider's web, which is firing out. But it'd be nice if we did multiple, wouldn't it? So let's set that up. Instead of just shooting out one spider's web, let's like get a regular pulse of them firing. So we'll go to the emitter. Let's go to the emission tab and we'll change the emission mode from shot to pulse. And let's just see by default what we get. There we go. So there's the first one, second one, third one, fourth one. So I would say it's maybe a bit too quick. Let's put it back to every 50 frames, the interval of those pulses. Nice. Cool. So now the final bit of the simulation, I think, what we should do is have this, our web shooter disk kind of rotating in different directions when it shoots. So we can set that up really quickly and easily with a Cinema 4D vibrate tag. So we'll go to the web shooter, we'll go to tags, Cinema 4D tags, and let's put on a vibrate tag. And we're going to enable rotation and put the frequency on 1. And I don't know, let's just try 50 and 50, see what we get. Okay, so one thing I'm looking at, it feels like the web's a little bit too regular. And this could be, let's make a few adjustments. So let's just bring the rotational segments down to 20. In the disk this is, so now we're going to get fewer particles. Yeah, that's probably looking better. And I think we've probably got too many disk segments. Let's put that down to 10. Yeah, that's looking nicer. That's definitely looking nicer. We could perhaps in the constraints try putting the connection limit down to say 10, so we've got fewer connections. Yeah, maybe a few more than that, maybe 20. So that's looking quite good. Obviously, you can make as many adjustments as you like. So I'm not really getting enough rotation variation in this from this vibrate tag. So let's put this back up to say like 100 each. Yeah, I mean, you make whatever adjustments you want. Let's just change the seed of that and see if we can get something a bit more interesting. Whoa, missed it completely. So let's just put that down a bit to 70 and 70. We don't want to lose it completely. That's just grabbed on and then stuck behind. So that's looking really nice. Excellent. So obviously, if you're doing this for real, you would spend an awful lot more time getting the perfect sim and getting the look that you want. But for our purposes, this is going to work fine. So what we will do is we'll move on to doing a quick render with Cycles 4D on this. Before we do, let's get it cached out. So I'm just going to do a very, very basic cache here. Let's go to... oh, actually, no, before we do that, I've forgotten one step, which is crucial. Now, constraints can't be rendered, but the only thing we want to render are these springs between particles. This is going to be our spider's web. So how do we do it? Well, we need to generate some trails. So let's go to generators and we will pick a trail object and let's drag in our emitter. Now, by default, what's going to happen is the particles are going to trace these trails from their path, which looks pretty cool, but it doesn't look like spiders' webs. So that's not going to work. What we need to do is choose an algorithm, and on default, there's no algorithm at all. It's just tracing a line from the particles. So for the algorithm, if we open this, you can see we've got a constraints algorithm. And that brings up, if this is interesting now, because this is a bit of a gotcha. If I go to the emitter, to the display tab, and switch off display constraints, so they're still there, but we can't see them. So look, you can see the particles are still being held together. Let's just display, let's make them a bit bigger. Okay, so the particles are still being constrained, but we're not seeing those lines. But we've got our trail object set to constraints, and we're not getting a trail where the constraints should be. Why not? Well, this is an important step. You have to say which kind of constraint from all of these different options that you've got, connections, forces, viscosity, in the trail object, you've got to say which one you want. Now, we're using birth constraints. So let's hit birth constraints, and now we're getting a trail where those constraints were. So this won't run quite as quickly as constraints because we're generating all of these trails, but it's still not bad. And now we have a renderable object in our scene to make our spider's web. So that's fantastic. So let's get this cached, and then we'll set up our scene for render. So we'll go to other objects, and let's bring in a cache object. The cache object, I would normally advise you to cache to external files. It's I think the best way of working with caches. But for this, we'll just put it in the internal memory because we're only caching trails and particles. So it's not going to be a huge amount of data. So saving it internally is going to work okay. So what do we need to do? In the inclusion, actually, let's exclude the emitter. Oh, actually, let's have a think. Let's exclude the emitter. All I want to do is cache the trails. That's all we need. All I'm rendering are these trails. So I've excluded the emitter from the cache. So let's go back to the object and let's build cache. So what have we got? We've got 500 frames. And this is whizzing through this cache really quickly. Yeah, I mean, it's going to be about 30 seconds in total. So once this is cached, what I'm going to be able to do is switch off the constraints, switch off the emitter, and then I should hopefully have a cached trail object all working perfectly. And so it's going to calculate really quickly. We'll be at scrub in the timeline, which means we can set up our cycles render and change the lighting really quickly and easily. So there we go, coming up to 500 frames, and it's going to be closer to a minute actually, but that's not the end of the world. And the cache is 180 megabytes. So what I can do is switch off the emitter, switch off the constraints, and fingers crossed, yeah. So now we've got our cached spider's web trails. Excellent. And if you really wanted to save processor power, then obviously we can switch off that as well. Get to that, switch it off. We don't need to see the shooter because we're not rendering it, and we've got our cached trails. Fantastic. Right, so now we are ready to set up our Cycles 4D render. We need to put up some lights, camera, and create some materials. So here we are in my Cycles 4D layout, and I've got my viewport here in this area, this window. I've got my Cycles real-time preview in this window. We've got our node area here where we'll make our Cycles materials, and then Object Manager and Attributes Manager where you would expect them. So what we have got at the moment is our scene, and if we hit play, obviously we've got our trails that are firing out, and they're sticking to our walls, our nice dynamic webs. So what we need to do is set up this render. So first of all, what we need to do, if we hit play on our real-time preview, you'll see that obviously nothing is rendering whatsoever. I'm just going to make sure that my device is set to CUDA. Yeah, it is. So nothing's rendering, and that's because we haven't got any lights in the scene whatsoever. So let's sort that out first. So we'll go to Cycles 4D, and we'll bring in the Cycles 4D light. Now here is our light, and if I move it back in the viewport, there we've got. Now by default, if I now come to my Object Manager, click on the Cycles 4D light tag, we can see that the light type is a point light, and I actually want an area light, so I'm going to change it to area. Okay. So we've got some light in the scene now. We're not seeing, if I scrub through, we're not seeing any trails. And that's because we need to put a material on our X particles trail object. And we haven't got any material on there, so Cycles can't see it. So let's make a material. My material manager is in this window here. Yours by default will be in this area. So we've got to create Cycles 4D. And let's pick a, let's go to surface, and we'll just pick an ordinary diffuse material. So this is the bog standard kind of color material, would be the equivalent in Cinema 4D materials. So if I take this diffuse material and put it onto my trail, now you can see that we're starting to render these trails. So that's cool. And what I'm going to do, I've actually put a trail tag on this trail object. And here is the Cycles 4D trail tag. So let me just take that off, because this is how we left the scene. So you can see that by default, if I put a material on a trail object, this is how it looks. And it's getting its kind of thickness from the trail object itself. But we don't want to do that. We want the tag to control the thickness. We want Cycles to control the thickness of these trails. We'll do it at render time. So to do that, we need to put that curve tag on. So let's just do that again, set that up. So let's go to tags, Cycles 4D tags, and we've got this curve tag. So we'll click that on. And now it gives you the options to set the thickness. And what this is saying is it will be 1 centimeter thick at the start of the trail, and then it'll taper off to 0 at the end of the trail. And that's just kind of the default setup. So if I just dolly in here, we can see that happening. You see this section, it's thicker and it gets thinner as it comes down. So obviously that's not what we want with our spider's web. We want it to be pretty much the same thickness all along. So let's just change that. And we want it to be really thin. So let's just try 0.1 and 0.1. So it's the same thickness all the way across. And what we're looking for is quite a kind of a wispy looking spider web. And as they accumulate, they'll become more obvious. So that's looking better. Let's just get this light and just increase the intensity. The strength multiplies at 100. Let's just put it on 500 to make it look a lot brighter. So there we go, we've got our trails, and the brilliant thing about Cycles and the real-time preview is we can play this, and you can see, look, we're getting that kind of feedback in the viewport. And I was playing through very quickly, but then if I stop that, it'll then start to clean up, and we can see these fantastic dynamic webs kind of accumulating on our wall surface. Okay, excellent. So what we want, we don't actually want them just to be a diffuse colour, these. We want them to kind of interact a little bit with the light. Now, one way of doing this to get light to kind of scatter within the trail, within the web, would be to use subsurface scattering. But that is quite a kind of an expensive effect. And these trails are so thin, it's a kind of a wasted effect. It works better when you've got an object with kind of contrasting thick and thin areas. And then you can really see how the light is scattering within the volume of that object. With trails, that's not really going to be obvious, and it's going to take longer to render. So subsurface scattering isn't really the strategy that we're going to go for. Instead, we're going to use a really fast rendering node called the translucent node. So let's do that. I'm going to go in my material editor. Here's the output of our diffuse, and here's our diffuse shader. And I'm going to bring in another shader. So right click, shader, and we're going to look for translucent. There it is. Let's bring in the translucent BSDF. Now, one cool thing about Cycles is you can see the effect of any individual node in a whole node tree by clicking this button and highlighting it. It kind of solos it. So this is showing us now what would happen if we had 100% translucency in our spider webs. If I just dolly in a bit, you can see that it's not transparent, but they're not as bright because they're absorbing some of that light. They're not just kind of diffusing it and reflecting it off. So that's why we want the translucency. It's also nice. I always like putting a little bit of colour in as well. Let's just put a tiny bit of blue in our translucency. That's a little bit too much at the moment, but once we mix in our diffuse, it's going to that's going to settle down a bit. But obviously, we can make adjustments should we need to. So what we want to do is mix these two shaders together. We want a little bit of diffuse, but we also want the light to go into it as well and have that translucent effect. So to do that, we just need a mix shader to mix these two. So we'll right-click, shader, mix shader, stick the top one in shader 1. Stick the bottom one in shader 2, and now these are being mixed by a factor of 0.5, and what that basically means is it's equally mixing the two together. If I move this factor down to the left, it's more diffuse and less translucency. If I move it over 0.5, it's more translucency and less diffuse. So let's just, I'm going to actually want that to be quite translucent, so I'm going to keep it higher up. And I'm just going to take this colour out for now because we are going to use some coloured lights, and so that might not be necessary, but we can always come back and colour that should we wish. Right, so let's have a look at what we're going to do now. So these wall cubes are obviously got no material on at all. They're just almost like they're just flat grey diffuse material. They're not looking very interesting. So what we're going to do is make these a highly reflective surface. So to do that, we're going to make a new material. Actually, before we do, let's get the camera set up. I want to show you a fantastic feature in Cycles which makes setting scenes up like this, especially with lighting, really, really easy, and it's very useful. So I'm going to set up a camera. So we're going to do this just in, we're going to make it a square frame, actually. So this is kind of your Instagram render. So let's just go to quite a dramatic angle here. So from the bottom looking up, and on this kind of angle, and that's going to look, I think that's going to look pretty dramatic. That looks good like that. So let's go to Cycles 4D camera to bring a camera into the scene in that position. We'll go to the tags, Cinema 4D tags, and let's put a protection tag on it. Where is it? P, protection, which means that we can't move that camera now. But here's the cool thing. You see this little icon is black, which means we're not currently looking through this camera. We're just using the default scene camera. If I hit white, see it pops back. So we don't want to look through that. So there we are, back to our camera, which we can't move. If I deselect it, but then put this button, which is camera lock, it means the real-time preview will stay on this view, but I can move around my viewport, move lights around, and get an idea of the angle that we're going to render, what those changes in the scene make. So that's really cool. So let's give these a reflective material now. So I'm going to go back to the material manager down here and go create Cycles 4D surface, and we're just going to do a bog standard glossy material. And this is a glossy material here, and I'll drag that and put it on our wall. Now at the moment everything's just gone black apart from these two little white bits, and what's happening is that this material is 100% reflective, and all it has in the scene to reflect is this scene light and possibly some of the spider webs. So the scene light is this square, and it's because it's an area light, and so it's just covering this area. So if I get my area light and I just move it in the X, can you see that the reflection is moving across the face of those cubes? So let's move this one up towards the kind of top cubes. And what we could do just to make this a bit easier is we're just getting this really sharp reflection and we can't see anything else. But if we add a little bit of roughness, it'll start adding a bit of diffuse lighting to that. So we can see the hot spot of our light, and then it's starting to spread out because we've made that metal a little bit more rough. So that's looking pretty nice. I'll just leave it like that for now. And what I'm going to do, I'm going to make this one a nice blue light to it's almost kind of mimicking a blue sky, I suppose. So let's just change that colour and add a bit of blue in there. Don't want it 100% value. So now you see we're getting a little bit of blue in the fall off. So that's looking nice. And that's illuminating our web a little bit and making that a little bit blue. So let's just get that light. Well, let's leave it at that for now. That's okay. We may increase the intensity. In fact, let's put the intensity up to 1,000. Or even more. Let's try 2,000. Okay, so we're getting this really nice blue kind of highlight on these bits of webbing and this nice hot spot. And now we want to kind of fill in some of these with another light. So what we're going to do, we want another light now. So how are we going to do it? Tell you what, let's move that back a little bit. Okay, and then up because I want it I want the hot spot near the corner. Yeah, that's looking nice. Okay, So now what I'm able to do, I can copy this light just by holding Control or Command, get this notch, and now I've got two lights. I'm going to put it down at the bottom. So that's really illuminated this and made it blue. So I'm going to change the colour of this new one. And I'm going to make this one a kind of a more of a sunlight. Okay, that's probably a little bit too much. And it doesn't want to be this strong. So remember, we get it 2000. I'm going to put it down to 1000. Maybe less. 700. Okay. Very nice. So let's just have a look. There's our webbing. So what I'd like to do is just move this around so we have a little bit of this in the reflection. So let's just have a look at this, where this camera is. So to reflect it in the scene, let's just move it. There we go. It's starting to creep in at the bottom about here. There it is. All right, maybe something like that. Great. So now what I want to do is illuminate a little bit of these. We've got these front faces of our cubes illuminated, but we don't have any kind of illumination further back. So what we're going to do to sort that out is, well, let's put a light behind as well. So what we'll do is we'll take light, this original light again, hold Control or Command and move it behind. And, oops, I made two. So this light now, this one we've just made is behind, but it's facing the wrong way. Area lights in cycles always are pointing to the Z positive, so it's pointing away from our objects. Let's move it back that way. And let's just get an idea. So it's here. Here's our camera. That's way too far back. What we're wanting to do is kind of illuminate the backside of these cubes a little bit. So I'm going to take that colour and put it way down, and then let's see, what I'll do is turn off the other two lights. Okay, so it's illuminating our the backside of our webbing nicely, but that's going to be a little bit too strong, I think. So let's put it down. And we want it to have some effect in the reflections. So we're not getting much on the corners. And one of the reasons for that is that our cubes have absolutely no bevel whatsoever. So what we could do a bevel in two different ways. We could go to the original cube that we've cloned and select fillet, which puts, that's way too big, that radius, which puts this fillet edge, gives us a bevel. But look how much more geometry. Look, as soon as I put that fillet on, look, you can see these nice highlights bouncing off the corners now from that rear light that we've created. But this is creating loads more geometry that we probably don't need to do, because, let's just take that fillet off, because if we go to our glossy material, in cycles, we're now able to do a bevel at render time, which is fantastic. So all we have to do is, if we right click on our material manager, go to input bevel, and if we put the normal from the bevel node into the normal of our glossy, it's not quite worked at the moment. Let's just put these other lights on. Because what's happened is it's got this, the bevel radius is way too big for the size of this object. So let's put this radius down to say it might even be 0.05. Let's have a look. Yes, so 0.05 is giving us a curved edge now. Still might be a little bit too big. Let's put 0.03, sorry. There we go. And now you can see we're getting this smoothed edge, and that new light that we've created is giving us these highlights on our cube. So that's good. I'm just going to put that up to 20. Very nice. So that's looking good. Let me show you a couple of cool things in the Cycles 4D node editor. So this node editor is one of the most intuitive and user-friendly one I think that exists in Cinema 4D. It is amazing. It's a couple of cool features you may not be aware of. If you want to, say we're zoomed out, if you want to zoom in on a node that you've got selected, all you have to do is press S, and it fills the material editor with that selected node, which is pretty cool. If you then press H, it frames all of the nodes within your node tree in here and kind of automatically zooms it correctly. So that's two really cool shortcuts. We can put a grid on, which is quite nice to help organize it, and then you can snap your nodes to that grid, which is really useful when you're trying to organize particularly very complex node trees. So let's just switch it off for now because we don't need it for this scene. But yeah, that's really, really cool features in the node editor for Cycles 4D. It's fantastic. Right, so let's just switch our lights back on. Let's go to a frame where we've got our spider's webs, and this is looking pretty decent, I think. I mean, obviously this is a quick render, a quick tutorial. You can spend loads longer creating your renders, but I'm pretty pleased with that. So what are we going to do? Let's just render out a few test frames, shall we, to see how we're looking. So I'll pause my real-time preview and I'm going to go to the render settings. So I've got Cycles 4D selected as my renderer. Let's go to the Cycles settings and do a couple of things. In the device, I'm going to make sure I've got CUDA selected. Let's have a look. We'll keep all the performance settings at default, so I'll leave those. Now the integer and sampling, I'm going to put these back to the default values. So when you open up Cycle settings, this is how it's going to look. You're going to have samples set to 4, which is hardly any, and everything else set to these 0 settings. And everything else in these whole render settings are the default settings. So let's just do a test render to see what we're going to get at the default settings. It's not going to look pretty, I can tell you that. So I won't save this. Let's just output current frame, and well, I won't save it, so we'll just render it to the picture viewer, this frame, and we'll see how it looks on the default settings. So it renders almost instantly, but as you can see, it looks awful. You see we've got all of this noise in the reflections. We've got a couple, these spots here are called fireflies, and you get that with unbiased render engines, especially when you've got kind of bright reflected light. You get these things called fireflies, and there are strategies to get rid of them. But the main problem with why this render looks so awful is because of the low sample settings, which means it just looks kind of like there's no anti-aliasing if you were using the standard renderer. So let's just shut that picture viewer. Let's go back to our proper view because we weren't rendering from the correct camera there. So let's just do it. Yeah, well look, let's just do another quick render now we're on the right camera. So you can see it doesn't look good, right? And we've got fireflies. So let's sort out the noisiness of the render first, and that's the easy fix. We just go to the render settings and we just need to increase those samples. So the default's 4, which is hardly any. We're going to need at least 25. I'm going to put it on 25. So what you're going to see is this is going to take way longer to render. It was almost instant before. So it's a lot cleaner, it's looking much nicer. So the web looks much, much better, doesn't it? That's looking fine. But we're still getting these spots, and these are the fireflies caused with bright lights, and especially when you've got lots of reflections going on. Now there's quite a few different strategies in getting rid of fireflies. Probably the easiest and most effective one is to make your lights bigger. If you have very small light sources, you're more likely to get these bright fireflies. If you have larger area light sources, then you're more likely to get them. So increasing your light size can often help. In this instance, I don't want to increase the light size because I'm kind of using them as a reflective tool in this material as well. So that's not going to work for us. So what else can we do? Well, what we're able to do is we can clamp the light values, both the direct light and the indirect light. And by clamping those values, we can prevent these hotspots. So how do we do that? Let's have a look. We'll go to the render settings, and we're going to go back to the integer and sampling, and you can see we've got these two settings, clamp direct and clamp indirect. Now the brilliant thing about clamping is it gets rid of fireflies. It's really quick and easy to do. The bad thing is you clamp the light, your image is going to be darker, and sometimes you want a really bright look. And how it works is this: on 0 there is no clamping at all. But then if you have it set to 1, that's kind of like 100% clamping. That's the most clamping you can have. So it's a bit counterintuitive, really. So I'm going to start just with the indirect, and I'm going to put a clamping value of about 5 on the indirect, which isn't that much. A value of 1 would be full clamping on the indirect light, but that might be a little bit harsh, and we might not need to go that hard. So let's just do indirect clamping of 5. Let's do a render and see if it improves our look. So it's going through. I'll just A/B it. So here is without. So look at this. This is really interesting. Let me zoom in. So this is without any indirect clamping, and look at all of these fireflies. You see these hot pixels. With indirect clamping of 5, look, they've massively reduced, right? Absolutely hugely reduced. So that's working really well. Let's do another render, and let's see if increasing the indirect clamping helps anymore. Probably won't. We'll probably leave that on 5 and include a bit of direct clamping. But let's just try it. So a lower number is a stronger amount. So let's try 3. And we'll render. Here we go. So here's the original without any clamping. Here's with a little bit of indirect clamping. And here's with more indirect clamping. And I mean, you can see they're certainly not as bright, but they're still there. So what I'm going to do, I'm going to leave it. I'm going to leave it as we had it. So let's just leave it on 5 for now. We can always go back. So this is less indirect clamping, and let's put a little bit of direct clamping on as well. And let's do a render and see what we get. Okay, so that's without anything. That's with strong indirect. This is with the same amount of indirect, but with direct clamping as well. So it's got rid of these hotspots. So these hotspots are caused by the direct light, and the other ones are caused by the indirect light. But you can see how much, if when we bring in that clamping, how much brightness it takes out of the image. But it's taken away those fireflies, so that's cool. Okay, so that's good. So let's just keep it at that for now. And now I think we can have probably slightly more samples. So let's put it on 30 samples. And the last thing I'm going to do is the light paths and ray depth. By default, there's only one. It only allows 1 ray bounce. I'm going to increase this to just 2 ray bounces. In fact, look, let me do it both ways too, so we can A/B it. So these are the settings: 5 direct clamp, 5 indirect clamp, and 1 max ray bounce with 30 samples. Let's do a render. Back to 100%. All right, so that's looking much cleaner. Very nice. So let's take that one off and let's go. And what I want to do is just increase the max ray bounce to 2 with a glossy depth of 2 as well. And let's hit render, see if we notice any difference. It should be a bit brighter, but it might be fractional. Let's have a look. Yeah, I mean, it's definitely brighter. You can see that the materials are illuminated way more because there are more the light is being bounced off the reflections twice rather than once, so it's brightened up that webbing. Okay, so we'll keep it on those settings. Great. So relatively clean render. You could maybe go higher in the samples if you were being picky about it, but I just want to get this one knocked out. I'm not going to bother with motion blur. I'm not going to bother with any depth of field effects on this, but of course you can do that should you wish. If you want to put that in, by the way, go to the camera, the Cycles 4D camera tag, and you've got your depth of field here with the radius size, and then you can add motion blur as well. And just make sure that you activate your motion blur in the render settings. That's down here. So in the Cycles 4D render settings, and then we've got a motion blur tab. Just activate your motion blur should you want it. But I want to get this out relatively quickly, so I'm not going to bother with that. Cool. So in the output, we've got 800 by 800. As I said, I'm just going to do a square render for this. And let's render all frames. And yeah, that's looking all right. So save, I'm going to do Open EXR, and the depth I've picked a lossy EXR, 16-bit. If you're doing this for production and you want more room for maneuver in the compositing stage, especially with very bright reflections, you'd probably want it to be 32-bit for all of that information. But for us, for this purpose, I'm just going to make it 16-bit, and I'll put a file path in here, obviously. Right, so what we'll do is I'll get that rendering, and I will come back to you when it's finished, and I'll let you know how long it took, and we'll see what our final look looks like. So here we are. We cached actually all 500 frames. So it's got a long animation, and it took 2 hours and 39 minutes to complete, which is not the end of the world. Average frame took about 14-15 seconds to render. Right, let's press play then, see what we've got. So we've got our really nice webs firing into this this grid of our shiny cubes, and it's looking really nice. Obviously it feels very, very dynamic indeed. We're getting this kind of like stretchiness. What I think I'd prefer, actually looking at it now, I'd rather there was a little bit more breaking, so we could perhaps have reduced that breaking percentage in the constraints. But I really like the look. It feels really dynamic, and I think it's working well. A couple of things to note with this technique. The problem with rendering constraints in this way is that the constraint itself isn't dynamic, so you are going to get some intersections between the trails and the cubes, the collider objects. It's only the particles themselves which will collide accurately with those. So depending on the scene, that may cause you problems, but with lots of very wispy web trails like this, I think depending on the angle and the camera position, you can kind of get away with that. I think it still looks very effective, and you don't necessarily notice the fact that there is geometry and trail intersection. But fantastic technique. Go away and try it on your scene. Obviously, don't just feel like you have to replicate this. Do whatever you want on whatever scene, and I'll really look forward to seeing what you do with this fantastic technique of using these dynamic particles and constraints to create this really nice sticky webbing.